PHYS2120. This video is about how to add forces that are not in a line. And so if we have three charges, and let's say we have charge 1, negative 6 nanocoulombs. You'll notice we're letting negative be blue. And positive 18 nanocoulombs for charge 3, right here in the center at the origin. And over here, 4 centimeters along the x-axis, we have charge 2, which is positive 2 nanocoulombs. So if we're going to add these forces together, there's some steps that we have to go through. Now, the first thing we have to do is draw a really good picture. And the better the picture, the more detailed it is, the easier time you'll have doing your homework. So in this case, we need to know the radius between these, because remember Coulomb's law, it involves forces and distances in meters. And so right here you can see the radius between charge 3 and charge 2. We'll call this distance right here radius 3, 2. Now, that's 4 centimeters, but we have to use meters. So we're going to call that 0.04 meters. And that's what goes in our formula. Also, this is 18 nanocoulombs. Now remember, nano means times 10 to the 9th, negative 9. And so this would have to go into the formula as 18 times 10 to the negative 9 coulombs. Likewise, positive 2 nanocoulombs is 2 times 10 to the negative 9 coulombs. Now, the other distance is between charge 1 and charge 2. And the radius is not along the x or the y-axis, but is in a straight line between charge 1 and charge 2. And so then we have to remember what we learned about the Pythagorean theorem. Turn it into a right triangle and you'll see it. This is a 3, 4, 5 triangle. And the hypotenuse is the square root of the x squared plus the y squared side. And so that's why, 3 squared plus 4 squared, that's 9 plus 16, that's 25. And the square root of 25 is 5. So that's 5 centimeters. But again, we have to remember that that's 0.05 meters. And this is negative 6 times 10 to the negative 9th coulombs. Oftentimes when you get a homework problem, it will be given to you in terms of centimeters and nanocoulombs, or even picocoulombs, or millicoulombs. You have to do these conversions before you go to the next step. Also, we are not interested in the forces between charge 1 and charge 3. We're going to assume that we just nailed those down and they can't move. We're only interested in how these two charges are putting forces on charge 2. So we're going to take an extreme close-up on charge 2 right here. And we can see that the force from the positive charge on the positive charge will be pointing this way. That's the force of charge 3 on charge 2. Now, because this is a negative charge and a positive charge, charge 1 will be pulling on charge 2. And so that force will be along this line. Now, you'll notice that I have an angle in here. These angles are very important. In this case, I'm not going to worry too much about exactly what that angle is just yet. I'm just going to keep up with it. But I know that force 1, 2 points along that angle back toward charge 1. So here's the steps we're about to use. Step 1, break your forces down into x and y components. Step 2, find the sum of the forces in the x direction and the sum of the forces in the y direction. Step 3, find the magnitude of the total force. And the total force is the sum of the forces in the x direction squared plus the sum of the forces in the y direction squared. And the reason this works is because we're using the Pythagorean theorem again. Now, finally, to find that actual angle of the total force, we use inverse tangent. And again, we're using the sum of the forces in the y direction divided by the sum of the forces in the x direction. Now, this is not that angle. If you remember from a previous video, we said an easy way to get an idea of where the total force will be is to turn this into a parallelogram. In this case, it looks kind of like the state of Tennessee. But you can see if I take this force and then I add this force, just basically click and drag this force here, that the total force between all the pushes and the pulls, the total force will be pointing in this direction. And the angle that you are finding here is right there. That's the angle. At the end of the day, when we find a total force, we need a magnitude and a direction. The magnitude is the total force, the amount of push, and the direction is an angle as measured from